This chapter focuses on the analysis of RETs that have a longitudinal focus by incorporating 3 or more repeated assessments of the same constructs, such as an outcome and/or a mediator. Usually, one of the assessments is a baseline measure and another is an immediate post-test measure. In studies that use multi-session interventions spread out across time, researchers sometimes obtain additional assessments during the treatment, say at mid-treatment, often with the idea of identifying early responders to the treatment or to identify people who have little hope of responding to treatment over the long run. In other studies, additional assessments are made after the immediate post-test to document the persistence or decay of intervention effects over time. There are many variants of longitudinal RETs. In addition to trials with follow-ups and mid-treatment assessments, I also address in this chapter the analysis of interventions designed to alter trajectories or growth curves, interventions to affect time-to-event phenomena such as survival analysis, and RETs that have intensive longitudinal structures such as daily diaries or electronic monitoring. The presentation is eclectic because my focus is on explicating core concepts that lay a foundation for longitudinal modeling. Issues include specifying time lags to use in RET designs, facet analysis of causal inference in longitudinal research, the assumptions of stability, stationarity, and equilibrium, contemporaneous and longitudinal assessments of reciprocal causality, addressing confounds, autocorrelation and autoregression, measurement invariance across time, between person and within person analytic frameworks, the traditional cross-lagged panel model, and full versus limited information estimation in longitudinal RETs with many follow-ups. After considering these building blocks, I describe different forms of statistical analysis that can be used in longitudinal RET designs, including SEM-based fixed effects analyses, SEM-based random effects analyses, generalized estimating equations, also known as GEE analyses, latent growth modeling, time-to-event modeling, and dynamic structural equation modeling. This chapter is long, and like several other chapters, is not amenable to processing in a single setting. After reading the initial foundation sections, you can read the remaining sections independently depending on your needs and interest. Skim them as you deem fit and your interests dictate, and then zero in on sections that are directly relevant to your needs. Good luck.